How large machinery, pinion and gear wheels are made. Step by step, why big gears matter. Brother, have you ever looked at a giant machine and wondered how those massive gears are even made? Without gears, heavy industries like mining, construction, and shipping would stop. According to mechanical design journals, gears are the backbone of power transfer in machines. The good news is, learning the basics of how they're made gives you a whole new respect for engineering. Stick with me, buddy, because we're about to uncover the full process, step by step. Next up, let's talk about the first raw step, choosing the right steel. Here's the deal, buddy. Gears aren't made from just any metal. Research from ASM International shows that high-strength alloy steels are the standard. Why? Because they need to handle extreme loads without cracking. The solution is simple. Always start with steel that's tested for hardness and durability. Practical tip: manufacturers usually preheat treat bars before cutting. Curious how those bars turn into gear blanks? Let's roll into that part. Now, brother, this is where the raw steel becomes something useful. Fact: forging makes the metal grain stronger, reducing the risk of failure under heavy pressure. The solution manufacturers use is hot forging, shaping heated steel into a rough disc. Tip for beginners in manufacturing: always control temperature, because too hot or too cold ruins the integrity. Now you're probably wondering, how do they go from a rough blank to precision gear? The next step answers that. Here's the reality. Forging alone won't cut it. According to Modern Machine Shop magazine, precision machining is where things take shape. The solution is lathes and milling machines shaving the blank into exact dimensions. Tip: manufacturers always leave some extra material for finishing. Ready to see how gear teeth appear? That's coming right up. All right, buddy, this is the fun part. Fact: gear teeth are cut using hobbing, shaping, or broaching machines. These machines guarantee identical spacing for smooth power transfer. The solution is to pick the right cutting method for the gear size. Practical tip: large gears often use hobbing because it's faster for big surfaces. Next, let's explore how these teeth stay strong under stress. Here's the deal, brother. Raw cut teeth are still soft. According to metallurgy studies, heat treatment hardens the surface while keeping the core tough. The solution is processes like carburizing or induction hardening. Tip for engineers: always test hardness after treatment, or you risk failure in the field. Wondering how gears get that shiny, smooth finish? That's our next stop. Grinding is where gears get their precision. Fact: even a tiny error in tooth shape can cause vibration and noise. The solution is gear grinding machines that polish every tooth. Pro tip: always check alignment, because one wrong angle ruins the whole part. Next, let's look at how pinions differ from gears in this process. Pinions are the smaller partners in gear systems. Research shows they take more stress because they rotate faster. The solution is making them from the same strong steel, but with even stricter machining tolerances. Tip: pinions often require deeper case hardening for durability. So how do manufacturers check all this work? That's where inspections come in. Buddy, nothing leaves the factory without testing. Fact: inspectors use tools like coordinate measuring machines to check gear accuracy. The solution is verifying tooth profile, hardness, and balance. Tip: ultrasonic testing also ensures there are no cracks inside the gear. But you might be wondering, how do these giant gears even move around the shop? That's next. These things weigh tons, brother. Fact: cranes and heavy lifters are needed just to move them. The solution is proper rigging and handling methods to avoid damage. Tip: never lift gears by their teeth, always by strong lifting points. Next, let's see how gears are fitted into big machines. This is where the magic happens. According to engineering reports, precise alignment during assembly is key to gear life. The solution is using laser alignment tools and torque-controlled bolts. Tip: lubrication systems must be installed correctly to prevent wear. So what keeps these gears running smoothly for years? Lubrication is the answer. Without oil, gears won't last. Fact: tribology studies show that 70% of gear failures come from poor lubrication. The solution is continuous oil baths or forced lubrication systems. Tip: always monitor oil temperature and cleanliness. Curious about how industries keep gears reliable? Maintenance is the key. Brother, big gears aren't set and forget. Fact: scheduled inspections extend gear life by decades. The solution is regular checks for cracks, wear, and oil condition. Tip: vibration analysis is a common method to predict failures. So what happens if a gear is too far gone? That's when restoration comes in. Sometimes replacement isn't an option. Fact: companies use techniques like welding and regrinding to restore worn gears. The solution saves cost and time. Tip: always recheck hardness after welding, because heat can soften metal. Next, let's peek at future innovations in gear making. Here's something cool. 3D printing and advanced alloys are changing the game. Studies show additive manufacturing can make prototypes faster than ever. The solution for the future is combining traditional forging with new tech. Tip: keep an eye on hybrid methods, they're gaining ground. But let's circle back, buddy. Why does this all matter to us? Without these gears, industries like mining, ships, and wind turbines wouldn't move. Fact: gear systems transfer thousands of horsepower every day. The solution is keeping manufacturing precise and reliable. Tip: always respect the engineering that goes into each gear. Next, let's reflect on what we've learned so far. So far, we've covered steel selection, forging, machining, cutting, heat treating, grinding, inspections, assembly, and future tech. Fact: each step builds on the last to ensure reliability. The solution is teamwork across design, metallurgy, and manufacturing. Tip: always think of gears as both art and science. Coming up, a motivational note just for you, buddy. Brother, if giant gears can be forged, shaped, and polished into something so strong, so can you. Life will pressure you, heat you, and grind you down. But in the end, you'll come out tougher and sharper. Stay focused, stay positive, and keep moving forward. Now let's close with some final thoughts on gear making. Manufacturing pinions and gears is not just metalwork, it's precision, patience, and dedication. Fact: even the smallest mistake can cost millions, but the right process keeps industries running. Tip: whether you're an engineer, a student, or just curious, remember that learning how things are made gives you new respect for machines. Ready for the wrap-up, buddy? Let's go! And there you have it, the full journey of making massive pinions and gear wheels from raw steel to finished part. Brother, I hope this gave you insight into one of the coolest processes in engineering. If you found this useful, like, share, and comment your thoughts or experiences. Disclaimer: consult a professional if you plan to work with heavy machinery or tools, as safety always